This is video number 3 for section 5.5, difficult case where A and B are not given. This time our example problem comes from the world of business. We're looking at the number of employees of Twitter, and I believe this is actual data. So we've got some years, we've got how many people worked for Twitter in those years. My let statement, E will be the number of people, and T will be number of years since 2005. All I have to go on this time is a bunch of data, so I'm going to have to go ahead and make a scattergram. Before I do that, I do have some adjustments to make. Since T is years since 2005, I'm going to have to call this 3 and 4 and 5 and 6 and 7. And now I'm ready to head to the calculator. Let's put the data in quickly. So I go to Stat and choose Edit. I'm going to have to clear out some old lists. So up to the name, clear and enter. Up to the name, clear and enter. And then let's enter in our new data. I've got my T values in the L1 column, and then I'll put the employee information in the L2 column. And then I need to go to the y equals area, clear out anything that's in there, then turn on the plot by going up to it and hitting enter, and then finally zoom, and 9 takes me to that perfect window where I can see my data. And you can see from the picture here, this is very much that exponential pattern. I mean, really, it's remarkably similar to that exponential shape that we've been looking at. So we should use an exponential function. If you glance at the handout, it says our next step is to pick a couple of points to use to create a model. Probably a good idea to avoid the first and last points. Something in the middle might be better. I think I'm inclined in this one maybe just to use the second one and the fourth one. I feel like if I connect those, I ought to get a reasonable model here. Let's write down those coordinates. So we want the second one, we said, and the fourth one. Let's write them as ordered pairs. And now I'll begin the work of writing the equation. This is the one that's kind of tricky because I don't have the y-intercept. My x's aren't going up by 1, so I don't have the b. I'm going to have to do this the long way. That was the one where you go to the exponential model, y equals a times b to the x, and you plug in both points. Remember, you want the one with the higher exponent on top. X is the exponent, so I'm going to start with the one with the 6 there. 350 equals a times b to the 6. And then the second one would be 29 equals a times b to the 4th. This is now a system of equations. Remember, the secret here is to divide the two equations because the a's cancel out. And for the b's, I can use that rule of exponents, the one about subtracting the two powers, 6 minus 4. 350 divided by 29 is not a nice number, so I'll just leave that as it is. And then to get b by itself, I'm going to go ahead now and use that reciprocal power idea. So raise each side to the 1/2 power. And I'm set. B is now something I can grab right off the calculator. I got b is about 3.474. It says to round it off to 3 decimal places in the instructions. Then to get a, I take this, I go back up to one of the two equations from earlier. I usually pick the one with the smaller numbers in it and substitute that value in for b. And solving for a now is very, very easy. This here is just a giant number. And so I just need to divide both sides by that number, and a will be by itself. The left side of this is now something I can just directly type into the calculator in one step. I rounded to the nearest tenth, as it says in the instructions, and now I can write down the model. Let's use the right letters. We have E equals 0.2 times 3.474 to the T. Let's go ahead and try it in the TI and see how it looks. I need to go to the y equals and add that equation in. I'll have to use x in place of the t. And then I hit graph. And let's see what we got here. Well, that's pretty good. It goes a little bit too steep here at the end. Maybe I should have used the second and fifth point to do a little bit better. But this is close enough for our purposes. Let's answer some quick questions now about the model. Let's see, this one says, say what the e-intercept means. The e-intercept would be the y-intercept. We found that already. As an ordered pair, it would be 0, 0.2. The t is years since 2005, so this is saying something about in 2005. The 0.2 is people, is employees. I can't really have 0.2 of a person. That would round off to 0, actually. So I think what we're saying is in 2005, there were 0 employees at Twitter. And that very well may be true. I'm not sure what year Twitter began, but that's what our model is telling us. How about the real-life meaning of the B? Well, we've been doing that the same way every time by talking about the constant percent. And I have to find that using this formula, b minus 1 equals r. That's going to give me r equals 2.474. That's r as a decimal. If you want r as a percent, you're going to have to move the decimal point 2 places over to the right. This is a giant percent, 247.4%. Remember how we would write those sentences? We would start the number of employees at Twitter has been, and then we use the word increasing or decreasing. Clearly here it's increasing by, and here's where the constant percent comes in, by 247.4% per year. That's large. That's why those numbers are going up so fast. Letter G, also by way of review, what if I wanted to predict the number of Twitter employees today? Now, depending on when you're watching this video, you may have to use a different year. I'm going to use 2018. I have to go back to my let statement. T stood for years since 2005. So if I want to use 2018, that's going to be represented by T equals 13. And all I need to do is take that 13 and stick it up here into my model. Let's write that down. And then I just type into the calculator. And I got a pretty large number there. This is starting to seem hard to believe. 2 million employees at this point. Finally, we get here to letter H. Letter H is really the only new part of the whole thing. Everything else is stuff we did at the end of chapter 4. Letter H, when are they going to be up to 10 million employees according to our model here? Well, the reason this is new is I'm going to have to take the 10 million and put it in place of the E and then solve for T, and that's going to involve using logs. Do I have to use all those zeros? Unfortunately, yes, because E was not measured in millions. It was measured in people. The rest of this is really the same thing we did in the other couple of examples. You might even want to pause the video and just try it yourself. The steps are the same. If I want to use logs, which I need to deal with this t, I'm going to first need to address the 0.2. It's in my way, so I divide it there on both sides. If this comes out nice, which I think it does, you could go ahead and divide it, but it's not necessary. You can always just leave it like this. Now I introduce logs, log the left side, log the right side. I do that so that I can take this t and bring it to the front, and then divide by that log on the right hand side there. And all that's left is to reach for the calculator, type this in, and figure out t. I got t is about 14. If I go back to the let statement, that means we're saying the year 2019. And now I'm pretty confident that we're dealing here with model breakdown. I'm finding it hard to believe that Twitter will have 10 million people working for them. That doesn't mean we've done anything wrong. This is normal. It just means that during the early part of the company's history, they were growing exponentially. They were adding people like crazy, but that can't go on forever. Otherwise, you get into these millions of people. So obviously, at some point, they must have slowed down. As you can see from these examples, the homework is going to have a lot of stuff in it that you've done before, which I think is great for review. Really, the only new part is this process of dealing with the logarithms.